concept we talked about that we see every single day is symmetry. When we look at the meaning of the word symmetry, it's Greek for symmetria, or agreement in proportion. Basically, things that are patterns that are going to repeat. One of the most common examples is of a butterfly. We see that a butterfly has wings that really look the same on both sides. So we would call that symmetry. Now, we have to be careful if we're very, very picky. Sometimes there are teeny tiny differences, like our body. The left side and the right side will not ever be 100% perfect, but you know, from a quick glance at it, they look exactly the same. So if I were to draw a line right down the middle, I could fold it over and it would repeat. It would be the same exact pattern. And that's what we call symmetry. So let's take a minute to look at some of the symmetry in shapes that we see. So if we take a look at some symmetry in nature, we can begin to draw lines where we think both sides would look the same. And some patterns are going to repeat multiple times. So it won't be just one line that is going to have symmetry or one side, but it might be a repeating pattern which has lots of lines of symmetry. So for example, I can draw a line down the middle of this bird, and you know, if we looked with a microscope, they might not be exactly the same, but from far away they look very symmetric, very even. The left side and the right side are symmetric. Like we said, an example would be a butterfly. I could put a line there on the butterfly, and right through the middle, it would look then that both sides are the same. Now, it won't always be just one line, so let's take a look at the flower here that's next to it. Now this has symmetry. We can draw a line there, and if we fold it over, both sides would be generally the same. However, I don't have to draw the line there only. I could, let me move that out of the way. I could draw it this way, and again, if I folded this side over, it would be the same. We call folding over a reflection in geometry. But it doesn't have to be in the middle of the flower petal either. So let me pull that back up. Where did my flower go? So let's take a look at more or less from here to here. So it's not cutting through the petal, but still, again, we can fold it over. So if I started to draw all the lines of symmetry, I would go through all the leaves, halfway through all of them, and then the space next to them, and then do it again here, and then do it again in the space next to them, and then do it again here. So this particular shape is going to have many lines of symmetry. And it's one of the reasons it looks so even and beautiful. So we don't have to only have one line of symmetry. Things that might be more complicated or have even sides in multiple places will have multiple lines of symmetry. So we can do that with the flowers. We can do that really with a lot of different shapes and things we see both in nature and things that we build. So if we take a look at some shapes that we're familiar with, we can even sketch them out on your paper and see if you can find the lines of symmetry. Now notice that the sides of these shapes are even. So symmetry works with even shapes. If a shape isn't even like this, it doesn't have symmetry. If I drew a line here and folded it over, both sides are not the same. So the left side would look more like that if I were to kind of try my best to repeat the pattern. So there are a lot of things, probably more things, that don't have symmetry than those that do. So I could draw a triangle. If the sides aren't all at least two of the sides aren't even, we're not going to have symmetry. If I draw a line here, this side's longer. If I drew the line here, again, you could see that they're not even on both sides. It wouldn't flip over and match exactly. So when we look at these shapes, we'll start with a triangle. We can cut it down the middle. There's one line of symmetry, right? But if we take this triangle and I say this is the top and I go down the middle, and we'll call this B and C. If I rotate or flip it around so that C's up here, I could do the same thing, right? I can go down straight through the middle. So let's take a look at what that would look like here. I can go this way through the middle, down towards the other side, and this pointy tip, this acute angle, we're going to go down through there to the other side. So this triangle that has three even sides will have three lines of symmetry. These particular shapes that have even sides that are exactly the same, and a hexagon and a pentagon and a square, they're going to actually have the number of lines of symmetry as they do have sides. So when you have three sides in a triangle, you have three lines of symmetry. Four sides in a square, it's going to have four lines of symmetry. Down here and here, and they would fold over and be the same. I could do it that way or that way, through the middle. And I could fold it down and they would be the same. However, I could also go diagonally, and when I fold it over, they would be the same. So as I mentioned, it's going to have four lines of symmetry that we could draw. So you could keep practicing if you wanted to. We can go here 5 from the pointy tip, it's an obtuse angle, to the middle of the other side. We can get this pointy tip, go down the middle, this pointy tip, go down the middle, and this pointy tip, go down the middle, and this pointy tip, go down the middle. So that one has 5 lines, it has 5 sides. So I think this is an octagon, has 8 sides, it's going to have 8 lines of symmetry. From the middle of each side, that'll be 4 of them. However, from corner to corner, we'll also cut it exactly in half. So I can go corner to the opposite corner, and it'll have 8 lines of symmetry. And of course, using a ruler and something with straight lines will make it a lot easier. So here's a hexagon, has 6 sides. It's going to have 6 lines of symmetry. Down each middle of the line, but then we can start on each pointy tip and go to the other side where it's pointy. And that is an example of lines of symmetry. So again, you're going to see all over the place things that have repeating patterns like this, and we tend to use symmetry to build things and make designs, and in video games, and in jewelry, and in artwork. But not everything has symmetry. Symmetry is a special characteristic. So hopefully that gives you a nice review of symmetry. I tend to think of a butterfly. That's the first thing I was taught about with symmetry. Hopefully that helps you review a bit. I know that you're learning a lot.